the past few years, we have been studying quite a significant thing in our lives. And it's actually pretty fascinating. So, for the past few years, we have been trying to see what a high temperature and a heart rate would do to to our cognitive performance as humans. And so, we wanted to check that out and see what would happen. So, in our research, we would raise the temperature and see what would happen. We would check the heart rate and see what happens there. And we would do that just to check what was happening in the cognitive performance of our subjects. Our subjects were all volunteers, and we'll go over what type of subjects we had a little bit later. But as you can see, why was this even important? Why did we choose this? So just in the last year, just in Australia alone, due to heat-related work, people have worked not to their highest performance. So just in the past year, Australia has lost $6.2 billion just to that alone. The economic loss is quite significant due to heat-related stress in work. Just in China, we can see that they lost 1% of their GDP due to this heat-related work stress. And so they lost 1%, and that's quite a lot for one of the biggest economies in the world. And if we look at like a poorer functioning country that's not as rich as China, we can see that heat-related stress would be causing a lot more damage to that GDP. So we want to find a way to help that. And so we think that this research study will be a start to help find out what we can do to better be prepared for this type of thing. And let alone, just in China alone, we can see that 26,800 people died in China from heat-related deaths. That's quite significant. And again, if it was in a poor country, we could see more deaths than just this.
For the design of our experiment, we built a 4-meter by 3-meter climate-controlled room. This way we could monitor the climate and we could change the climate depending on how we wanted to conduct the experiment for the different results we were looking for. We had 3 desks placed in our small chamber. One desk was for the observer, and the other 2 desks were for the 2 subjects in each room. This way, they were facing opposite ends of the room. They weren't able to look at each other's monitor as they were taking the test that we administered. Each desk that the subjects were in had one computer, a keyboard, and a mouse, which was all they needed to perform the tasks that we administered to them. Our subjects were chosen through a variety of surveys. We wanted to make sure that we got the best possible subjects, that we weren't going to have any confounding variables in our data, because there are lots of other conditions that can increase heart rate as well. So we wanted to make sure that everyone was healthy. So we administered surveys around the campus in China, and we got lots of feedback, but we sorted through them all, and we eventually came up with 105 subjects that will fit our criteria, what we were looking for to be able to participate in this experiment. None of them had heart disease. None of them had cancer. None of them had any form of lung disease or other disease that would cause them that would diminish their performance ability. None of them were smokers. They were all very healthy young individuals. They were either postgraduates or undergraduates between the ages of 20 and 30 years old. Once the subjects were chosen, they were hooked up to a heart rate monitor chest strap before they entered for the experiment. This way, we were able to monitor their heart rate throughout the experiment as we administered specific tests onto them. So they wore this throughout the entire time, and this allowed us to record the data that we were going to need. Our subjects were administered a variety of tests. The first test being the neurobehavioral test. This one evaluated the indoor quality on work efficiency. So how the temperature and how things indoors in the climate-controlled room affected their performance. They were then administered a visual learning test, which had various shapes that they were told to memorize and they had to match later. They were also administered simple math, addition and multiplication. This math wasn't too difficult, but it was given and they had a time limit to complete the problems. They were also administered the Stroop test, which is this test here that has different colors and then different words corresponding to different colors. And the subjects were told to read the word, but not the color that the word is written in, not the color ink that it was in. They're also given overlapping and redirection tests, which measured perceptuability and being able to look at shapes in a 3D sphere. They also took a few typing tests where a prompt was given to them on the screen, and they were then asked to type the prompt, and we recorded how fast they were able to complete this and how accurate they were able to complete this as well. And the final test that we administered to our subjects was the D2 test. This test examines their attention and their concentration abilities. And all these tests were administered through each experiment that we conducted, and they were done in different climate changes as we were able to change the temperature in the building. They weren't completed on the same day. Each participant participated in one experiment. They were sent home. They had a couple days to rest, and they were brought back for a different temperature in the room, and they were administered the same tests. Throughout the experiment, they were also asked to report and to take self-reported surveys to measure how they thought that they were feeling. We wanted a self-reported work performance. This was on a scale of 0 to 100, 100 being they felt they were very efficient, and 0 being they felt like they weren't able to perform very well. They were also administered an alertness scale test. This was on a scale of -4 to 4, 4 being very alert and awake, -4 being tired. And they were also given a thermal sensation survey. This measured their hot and cold feeling, also on a scale of -4 to 4, 4 being hot, -4 being very cold. So in summary, we had each of our 104 participants participated in 3 separate experiments that each lasted about 175 minutes each. They were on separate days apart from each other. They were done in warm, cool, and hot temperatures. And they were all administered the exact same tests. The Stroop test, the multiplication test, the addition test, visual learning test, our D2 test. And they were all administered the same surveys as well to judge how they felt like they were able to perform. And these were done 3 separate times, and we recorded the results.
Now, the overarching main idea of our experiment was that high temperatures led to an increase in heart rate. This increase in heart rate was then utilized to measure any changes in cognitive performance that may have taken place in our test subjects. This little pictogram right here expresses just that in a much more simpler version. High temperatures lead to heat stress. Heat stress leads to thermal regulation. Thermal regulation leads to some form of physiological changes in the body, such as an increase in heart rate, as well as subjective responses such as discomfort, thermal acceptance, and thermal sensation, just how hot they were getting. This in turn led to some form of a decrease in cognitive performance. This decrease is what we're trying to measure, just how much of a decrease is actually taking place. As you can see, it's no real mystery that as we increase temperature, heart rate as well also increases. Right here in this diagram shows just that. The more we increase temperature, the more the heart rate tends to increase. Now, during the course of our experiment, there was about 1,478 viable samples without any real outliers that popped up in our data the more we collected information on our test subjects while they were being exposed to heat and while their heart rate was being measured, while at the same time measuring how well they performed on the test and how well they also think they performed, which was more subjective matter. This subjective viewpoint was also recorded. The test subjects were somewhat aware that this heat that they were exposed to, with the added addition of their heart rates also increasing, in some way or form led to them not performing to the best of their abilities. The subjects' heart rates went up, the lower their self-report scores were. The score was on a scale of 1 to 10, 1 being the worst, 10 being the best that they could perform under perfect conditions. And the next data that I'm about to show shows just that. It shows that there is more of a negative trend that is associated the more the heat rises and the more that their heart rate increases. When heart rate was increasing past about 80 to 90 beats per minute, you can see this negative trend start to occur. On some of the tests, however, it begins just before that. However, one thing to also point out was that there's also a potential sweet spot where this increase in heart rate also led to the best possible results of those tests. One being the Stroop test, visual learning, multiplication, as well as the D2 test. There is also other variables to consider. One that was then later debunked in the course of our experiment was, is gender a factor into variables that take place? In all honesty, it does not really matter what gender the test subject was, male or female. There's only 3 sections where it showed some slight significant results. Visual learning being the most out of the bunch. As you can see right here, males had a more bell-curved shape, while females had a more linear curve. Well, just linear trend. At one point, though, males were close to closing the gap between their female counterparts. At one point, visual learning was so close that they were almost the same, almost identical. Addition, typing, also the same trend. They were so close, almost identical, with some slight variation in between by 1 or at most 2 when it came to performance under the certain test. In summary of the data, the more the heart rate increased, the more their cognitive performance also decreased. It was an inverted relationship. Attention and long-term memory started to decrease and decline even farther at around 90 and above. Working memory and learning decreased at about 110.
So now that we draw to an end of this presentation and draw the end of our research, we wanted to show you why should you care about this. So we wanted to show you these graphs that we've made, and we want to show you in this lower left graph that our low cognitive performance to high cognitive performance. So as we can see in the low to high heart rate, that there is an optimal range there. We can see there's an optimal range, and it's very important to see that so that you, as a person, can find your optimal range of your heart rate and your cognitive performance in what type of heat environment and temperature would cause that to be the best for you. And so this can help you as a professor to teach better. It can help you as a student to learn better, find your optimal place to learn. And it can help you as an employee, as an employer, and it can, to find your optimal working time, your optimal working place, and be able to perform the best of your abilities. And it'll help an employer to make more money, to be able to help the economy grow. And so there won't be as much loss in the economy and not much loss in GDP as well. So look at this pictogram, it kind of explains itself, but it shows that all these things are related, and we want to show you that all these things are related. And we just want to say thank you for listening to this presentation. We hope you have a wonderful rest of your day, and we hope this will change the way that you think about the world around you. Thank you for joining us today. Goodbye.